Hello, and welcome to the next session in my webinar series on C++ Standard Template Library by Example. Today, we're going to continue our discussion of iterator adapters we started yesterday, and now we're going to focus on the so-called stream adapters that allow I/O stream objects to be integrated seamlessly into various STL algorithms, making them work and then feel like they're iterators. So without further ado, let me go ahead and share my screen, and we'll look at the place to get the code, and then we'll jump right into the discussion of the examples. So today's source code can be found in my GitHub repository in the C++ STL S-06 6.5 subfolder. And you can see we have a number of different examples that we'll look at here. Let's start by looking at the first example. This example is going to demonstrate the use of Istream and ostream adapters. So the purpose of this is, rather than having to explicitly extract and insert data in from I/O streams, from the streams that are used directly, instead what we're going to use is we're going to use stream adapters or iterator adapters to make the streams appear as if they're STL containers. And then we'll use the copy algorithm to manage the process of building the container, which in our example, just for kicks, we're going to sort. There are three types of stream adapters: Istream adapters, ostream adapters, and stream buffer adapters. This particular example is just going to focus on Istream and ostream adapters. So here's the example. You can see we're going to make ourselves an empty list of strings called myList, and then we're going to apply the Istream iterator adapter to take the cin Istream and then go ahead and pull the data in as basically an iterator, an input iterator, as strings. And we're going to keep going until we reach the end. And every step along the way, we're going to go ahead and insert the item that we read in, the string that we got in from the standard input, to an output iterator using the inserter adapter, the inserter iterator adapter that we talked about yesterday. And the way this is going to work is it's essentially a back inserter. We're just doing it this way for kicks. We're giving it the myList container, which is the list, and then we're telling it to put it at the end of that particular container. Let's just take a quick look at the Istream iterator stream adapter. You can see here that there's a couple of methods that matter here. One is this constructor, which is what we're using to initialize the first input iterator with. And what we're doing is we're passing in an Istream object by reference, and that's then being stashed away as a Istream pointer. And then we go ahead and kind of kick things off and read some data in just to start things up. You'll notice the second Istream iterator adapter that we're using is indicating end of file. And so it just sets a value of 0 or a null pointer here. So that's the way we're going to know that we're done. And then if you take a look at the various methods down here, you can see, for example, that we've got the star method, which doesn't do anything. We have the other methods that don't really do anything. But here's one that actually does something. The plus plus operation goes ahead and will read in from the stream that we've encapsulated here into a value at returning this. And the same thing for this post increment operation, plus plus, and so on and so forth. So this is basically going to be used to pull the data in from the container that we've wrapped by the adapter. So here's how it gets used, of course. We're going to read this thing in. And remember, we're just using the good old copy algorithm. We've seen this a gazillion times now. And it's just going to go ahead and read from the beginning of that sequence to the end. And every step along the way, it's going to go ahead and insert it using this inserter, which works like a back inserter. After we're done, we're going to go ahead and take the list and we're going to sort it. Note that a list is actually a bidirectional iterator style container. And so as a result, we can't use the sort algorithm that expects to work on random access iterators, but instead we're going to use the sort method, which works on, in this case, the bidirectional iterator list. It's actually part of the class itself. And then the final thing we're going to do, we're going to start at the beginning of the list, and we're going to iterate from beginning to end, and we're going to copy it to the ostream iterator. And that's kind of the other end of this thing. Here's the ostream iterator. You can see that in this case, we gave it an ostream iterator that was an ostream and a const char star delimiter, which in this case was the new line. And then this assignment operator that you see here, the assignment operator is the thing that triggers this because it's working as an ostream. sorry, it's working as an output iterator, so we want to write to it. And what's happening is it takes the value that's coming through here from the list, and it's going ahead and it's basically inserting that into the ostream that we tucked away in this constructor up here. And if there was a delimiter that was given, we go ahead and write the delimiter out after we've basically inserted the value into the captured ostream. So that's basically how the logic works here. Under the hood, you can see these are all value semantics. They're passing these things around, and they're storing the reference, or actually the pointer, to the ostream as a pointer, but it comes in as a reference. Okay, so going back over here, let's now run our program. And the program is going to say, now is the time for all good people to come to the aid of their party. And let's give that an exclamation point. And now we go ahead and end that input. And you can see that I went ahead and sorted it after I got it, so it comes out in sorted order, in ascending sorted order. So that was the first example I wanted to show you. This is just showing the Istream and ostream stream adapters and how easy they are to integrate with STL algorithms like copy in conjunction with other things like inserter adapters or back inserter adapters and so on and so forth. Let's now go ahead and take a look at the next example, 6.5.b. So this example is going to further demonstrate some of the concepts we've been talking about. And it's going to use the class template Istream Iterator to read elements from an input stream using the operator that's the extraction operator. And we're going to get the value of t, and then we're going to store it when the iterator is constructed, and each time operator plus plus is called. The iterator here is equal to the end of stream iterator value if the end of file is reached, and that's done by having this constructor with no arguments, which is used to kind of be an indicator or a flag that we're at the end of the stream. The only valid use of this no parameter version of the Istream iterator is to compare to other iterators when checking for end of file. As usual, don't attempt to dereference this thing. You'll get gobbledygook, with the technical term meaning that it won't be a meaningful value. This is just a problem, or not a problem, this is the characteristic, the behavior, or the semantics of the end method for all iterators returned from containers via the end method. Since an Istream iterator is an input iterator, you can't assign to the value returned by dereferencing it. It's a read-only like model. And this means that Istream iterators can only be used for single pass algorithms, because we can't assign to them. Let's go ahead and take a look at this. We make ourselves a vector, and let's see. Oops. We make ourselves a vector here, and this is going to then be empty initially. We go ahead and make ourselves an Istream iterator adapter called isiter and an ostream iterator adapter called ositer. And we then define ourselves another vector v, and then we have a value type sum here. And I don't necessarily have to do it that way. I could also have said auto sum equals 0. That would also work if I give it a different name than sum, of course, but let's use this one just for kicks. So what we're going to do now is we're going to prompt to enter a sequence of integers with an end of file to quit. And you can see what we're going to do here is we're going to read from the input stream iterator adapter from cin to the end of this thing, and we're going to do a back insert of each element. And then what we're going to do is we're going to take this and we're going to go from beginning to almost the very end, and we're going to go ahead and write the results to the output stream iterator. And notice the main difference between this and the previous example is we defined explicit instances of Istream iterator and ostream iterator. We made these as basically local variables as opposed to doing it implicitly by having anonymous objects created. Works pretty much the same. This arguably is a little bit more concise, maybe, depending on your point of view. And then what we're going to do here is, since we stopped before we got to the very last element in our copy, then what we're going to do is, assuming that we're not at the end, what we're going to do is we're going to go ahead and print the last element, and then we're going to say what the accumulated sum is of that value. And you can see here the sum is defined up there. I guess if I was really being conscientious, I would probably move this closer to where it's being used. And I go ahead and I write out the results here. And this will go ahead and accumulate the elements in the vector from beginning to end and print out the sum. So let's go ahead and run this. And it prompts us for some input. So let's say 10, 20, 30, 40, 50, 60. And then let's give it the end of file character. And you can see what it does is it prints 10, 20, 30, 40, 50. And then it goes ahead, as you can see here, and it prints the last element, v.back. That's the last element in the vector. And then it goes ahead and calls accumulate, which totals up the contents that's in that particular vector and prints the results. So this is also giving us a chance to kind of showcase the accumulate method. That, of course, is a standard STL algorithm. And you can see all it's doing here is it gets an initial value here. And this, of course, is a template that's parameterized by an input iterator and a class, which is going to be the thing that's used to total it. And we go through the range from first to last, as we always do. And every step along the way, we basically increment the count of init, which, as we saw here, would start out as 0. And we add to it what was ever in the container at that point. And we just keep a running score of that, a running sum of that. And then when we're all done, we can just return that as the result of accumulate. So that's illustrating how accumulate works. You'll notice that accumulate comes out of the numeric header file. So that's the second example I wanted to show you. This kind of illustrates a couple cool things. It illustrates how you can make explicit instances of Istream iterators and ostream iterators, and how you can then do copy where you don't go the whole way, and then how you can go ahead and use the operations here to accumulate the information and print the results out. Okay, I can see that Clang is telling us let's use empty, not size equals 0. So I think that's probably a good suggestion to make the code a bit more understandable. All right, next thing, let's go ahead and take a look at 6.5C. So as we've seen before, there's Istream iterator adapters, there's ostream iterator adapters, and the Istream iterator adapters, as you saw, are used to basically read the values, where the ostream are used to write the values. So they're used as output iterators, whereas the Istream iterator adapters are used as input iterators. And as you can see here, they changed the assignment of a new value to be an output operation by using the insertion operation, the less than operation. As you can see here, when we create an ostream iterator, you have to provide it with an output stream, like cout or cerr. And optionally, you can also provide it with a character string that can be used to separate the values being passed when you write them to the output stream. So here's what we're going to do. We're going to go ahead and make ourselves an ostream iterator we call OI, OI. And then we go ahead and we assign 6 to this and 88 to this. So remember, the star and the plus plus here are just syntactic sugar. What really matters is this assignment operator. And here we go. This is the assignment operator for the ostream iterator adapter. As you can see, it's going to take the value and it's going to basically insert it to the output stream, which was stashed away when we created the instance of that OI using this constructor here. And then if there's a delimiter, we go ahead and write that out as well. So that's what happens with the assignments here. Then what we're going to do is we're going to go ahead and create a deque that has the values 3, 4, 7, and 8. And much like we did before, just kind of illustrating we can use deques as opposed to lists or vectors, we're going to go ahead and copy the contents of this deque from beginning to up to, but not quite including the last one. We stop one before the end, and that's going to get written to the ostream iterator adapter. In this case, we're going to put a plus between each of these things. And then when we get to the end, the last one, we're going to go ahead and say d.end -1. So we're going to go ahead and go back 1, and we're going to print the result there. So that's going to be the last element there. And we could probably just have said, d.back. In fact, that's a good question. Let's see if we can say d.back. Yep. Whoops. It'd be helpful if I didn't give it a syntax error here. So we could also say d.back. That's the last element. But if we want to be even more obscure, we can say d.end -1, which is the last element, and then dereference it. And then again, we go ahead and use the accumulate algorithm we did before, except now we're working on a deque as opposed to the other data types we worked on before. Okay, so let's go ahead and run this and see what we get as output. So you can see that the first thing we do, and I probably should put a new line here just because it's kind of a different output. Let's go ahead and do that and then rerun it. So now you can see that we start out by making an ostream iterator that's going to write to standard output with a space between each of the elements, and then we write 6 and 8 to that. So we go ahead and put those things out into the ostream as if we're doing pointer arithmetic, which is kind of cool. And then we go ahead and we write out the contents of the accumulated deque, and we add up the results of the values. So that's illustrating yet more features. This is kind of focusing on the ostream part, as well as, of course, also using the Istream part. So now let's go ahead and take a look at our final example here. If I can get the thing to open. Let's say 65D. That's the one we want. And this is a really interesting one. This is yet another kind of stream iterator adapter. Remember, we've already talked about the Istream iterator adapter. We've talked about the ostream iterator adapter. Now we're going to talk about the stream buffer iterator adapter. And you'll see that there's a couple of variants of that. There's Istream buff iterator for reading and ostream buff iterator for writing to streams. And these template class objects can be used to read or write individual characters from or to basic stream buff objects. And so this is just a really, really fun example. I think I'm going to show it to you, and then we'll kind of talk about it because it's pretty crazy. In fact, let me tell you what. Let me go ahead and run it first, and then I'll show it to you. So here's what we get as the output. It says, here is a sample sentence for output. I hope you like this sentence out there. Perhaps not the most profound bit of prose in the English language ever written, but it gets the point across. I should probably put some Shakespeare in here to make it better. So here's what we're going to do. First thing we're going to do is we're going to open up a temp file name using the much maligned temp name method, which has been deprecated. I just haven't had a chance to rewrite this to use make stemp, but this is just a simple example. So don't write code like this in production code. I'm just trying to make a temporary file name for the purposes of getting this program to run. Then what I do is I take that temporary file name and I go ahead and create myself an ostream, which I call out, and I'm going to open it for reading and writing and also truncate, which means it's going to start being empty even if there's something already in it. And then what I do is I go ahead and I output to the OF stream. I'm writing to that file, right? So this is a file stream, an output file stream. I write to the file, here's a sample sentence for output. I hope you like this sentence out there. Again, not the most profound thing ever written. What I do now is I go ahead and so keep in mind that's been written to a file, right? So what I do now is I go ahead and I put the seek pointer to the beginning of the file. At the moment, it's at the end of the file because I just got done writing to it. Now I move it back to the beginning. And then what I'm going to do is, this is really cool. I'm going to construct myself an Istream buff iterator, and I'm going to give it the read buffer to that file. So remember, I wrote to the file, I moved the seek pointer to the beginning of the file, and now I'm going to get a read buffer to that particular content. Here is a sample sentence for output, that string that's in the file. And I'm going to connect it to an Istream buff iterator. So this is going to read this from a buffer that's associated with the file. And then I'm going to go ahead and create an Istream buff iterator, which will represent the end of the file. And then while I'm reading from the beginning to the end, it's going to read the contents out basically a character at a time. The file will be read a character at a time. And every step along the way, I go ahead and write the contents, and then I increment it by 1. And so this is going to basically iterate through that file one element at a time. And let's see if we can make this work or not. So you can see here what we're doing, and it's pretty low level, but these are the constructors. This is the constructor that we use to create this. We stash the read buffer in here. We give it the buffer. And then here's the ++ operation that we're using here, which is going ahead and basically advancing it by 1. Another way to do this, which I think is arguably even better, is to use the copy algorithm and write the code like this. So here's the copy algorithm. This is a little bit unformatted, but we can fix that. So you can see here that we're going to start with an anonymous instance of the Istream buff iterator. That's the input iterator, the first input iterator. As usual, we go to the last, which is just this no-op constructor for Istream buff iterator. And then we're going to write this thing to an ostream iterator, not an ostream buff iterator, but to an ostream iterator. So it's going to write to standard output. And when we run this thing, as you can see, when we ran it, it went ahead and took the contents of the file, which is what we gave it here, and then it wrote the contents of the file character by character to the standard output. And again, I think if we run it this way, we should probably get this thing appearing twice. Oh, I take it back, it just shows up once. Oh, I know why, because we didn't re-advance this thing. So we got everything that was underneath there. Let's go ahead and do this. Let's say hash if 0, and we'll get rid of this guy. Hash and if, and then let's go ahead and try to run this. And as you can see, it gives us the same result as before, which is what we want. So either of those approaches will work fine. This approach is arguably more concise. This approach is just showing you the elements one at a time. And then when we're all done, we go ahead and remove the temp file because we don't need it anymore, and that will clean everything up since it's a temp file. So that was the last example that I wanted to show today. This particular set of examples here was just illustrating the stream adapters, Istream, ostream, and stream buffer adapters. And you can see that they're actually very useful. I've been using them quite a bit kind of as a debugging tool when I want to print the contents of containers out and I don't want to have to write special print functions and so on. I just use copy, and then I use the ostream adapter to write to the output, usually to C out. So very useful little tools showing once again the orthogonal concepts of STL, where you can kind of mix and match things and you can adapt stuff. And even though we've looked at these examples earlier in other contexts, I wanted to kind of walk through it systematically to show you how the Istream adapter, Istream iterator adapter, ostream iterator adapter, and Istream buff iterator adapter, and ostream buff iterator adapter can be used. So if you like this video, please go ahead and give it a like and subscribe, and feel free to follow me on Twitter.